Okay, so it's now time that we get started on to the equations of motion. That's where students start to, especially students who aren't so good with their mathematics side of things, can find some trouble. And look, motion does get harder as we go along. So, look, I'm going to just first of all try to derive some of these equations of motion. And I guess at the moment, like as it stands, we've got 6 equations of motion here. Some of these actually just come from other equations. So I guess they're not really equations, it's just rearranging some of them. But let's have a look at, first of all, what terminology we're using. First of all, we're using x for displacement or distance, but I guess we're looking at an associated direction, and yeah, we would know x is displacement. If there's no change in direction, I guess you'd call it just distance. Now, u being the initial velocity, v being the final velocity, a the acceleration in meters per second squared, and t is time. Now, the first thing I'll say about equations of motion is that it's only applicable when the acceleration, when there's a constant acceleration, when acceleration is constant. So for example, if the acceleration is changing, like let's have a look at a velocity time graph like so. If this is our velocity time graph and it was to look something like this, well, we couldn't use equations of motion for, I guess, this section here, because the acceleration is not constant. It's obviously changing. It's accelerating very slowly, sort of in this area, and then it rises quite steeply. So we can only use these equations of motion for, I guess, constant acceleration. So for example, if we were to have a velocity time graph which looked like this, let's just say it started at a speed not 0, and we'll call this initial speed u, and we'll call this final speed v. We can only use these equations of motion for this. Now, that's all well and good. Now let's use this graph that I've just drawn to try and derive some of these. Let's have a look first of all at the first one. Is we know that the acceleration, by looking at this graph, is the change in speed over the time. So the change in speed, well, what is that? Well, the change in speed is this, I guess we could always say this change in speed is equal to the final speed, which we know as v, minus u. And another way I guess we could write that is sort of like our rise over run is our acceleration. So the gradient of this velocity time graph is going to give us the acceleration. And the acceleration is the rate at which the velocity is changing. So let's have a look. We've got v minus u. So how else could we write this equation? We've got the acceleration is v minus u on t. Now, if I was to multiply both sides by t, and then I would obviously, these t's would cancel out, wouldn't they? And what we've got left is v minus u is equal to at. Let's add u to both sides, add a u to this side, add a u to this side. We've got v is equal to u plus at. And that's looking pretty familiar because that is this one. We'll call this equation 1. So we've used, that's our first equation of motion, and I've just derived that for you, just using the, I guess, just from a simple velocity time graph. Now, the next step is, well, let's go ahead and see what else we can do. Well, I told you that the area under the velocity time graph gives you the acceleration. So if I was to find this area under here, and obviously under here, I've got to add these two things together, don't I? So let's go ahead and do that. And this time let's use, we're going to find, so therefore, the displacement, we'll call it displacement, it can be distance as long as there's no sort of direction, because distance is a scalar quantity. So the displacement is equal to, let's break this down. Well, first of all, the height of this this is a rectangle, isn't it? We've got a rectangle. The height of that is u, u being our initial speed, and then we multiply that by the change in time, or we'll just call it the time. And then we need to add the area of this shape up here. That's this shape in here, which is a triangle. And look, if you're struggling to work out that don't know the area of a triangle, you're in a bit of trouble. Half base times height. Well, the base is t, and the height is, well, what is the height? Well, it's v minus u, isn't it? Like, if you think about it in terms of, we start here at u and we go up to v. So I guess this height here is v take away u. Okay, so at the moment we've got this area, or this section of the triangle, this section here, that has a length v minus u times, that's length t. The height is v minus u, and then we've got to times it by the half because it's a triangle. So this is what we're left with, a half t v minus u. Okay, so where do we go from here? Well, I guess let me just sort of give you another formula, and that is that the acceleration we know is the change in velocity over time, isn't it? So we know that, and that is equal to v minus u over t. So what happens if I was to get this t over here? What does that equal? That's at, isn't it? A times t is equal to v minus u. Just doing some cross multiplying there. Okay, now v minus u, and let's just sort of put an asterisk here. At is equal to v minus u. Let's sub that in over here. So let's see what we've got here. So wherever we've got a v minus u, we can replace with at, because we've just proven that the at is equal to v minus u, or the final speed minus the initial speed. So let's go ahead and do that. What have we got then? We've got x is equal to ut plus a half. Now that v minus u is at, so we've got at times t, which is at squared. And funnily enough, that ut plus half at squared, wow, that's amazing. That's equation 2. These two are very, very common. Now, these ones you won't see too often. I wouldn't worry too much about it. Now, this one, I'm not going to derive this one, but we're going to use this one to then derive another, because otherwise we can go on forever, and you're probably not going to serve too much purpose now, especially when I'm not in class with you guys. So let's go ahead and I'm going to tell you that equation 3, we're going to use this equation 3, and then we're going to derive another equation, which would be, let's say, which one are we going to do? V squared equals u squared plus 2ax. We're going to derive this equation here, which is 4. Okay, so let's have a look. First of all, we've got equation 3. I'm going to use that to then try and get 4. So I'm just going to make some room for me now. Okay, so look, let's have a look at the equation 1. The very first thing I derived. We've got v was equal to u plus at. Now, if I was to rearrange that to find for t, what would I get? Well, first of all, I'd have to take u from both sides, which means it would have v minus u is at. And then I'd have to divide this side by a, this side by a, which is going to give us t is equal to v minus u on a. Now let's call that equation, let's sort of put an asterisk there, or we're going to sort of say, okay, I'm going to use that value there, and I'm going to sub this value for t in over here. Okay, so let's go ahead and do that. So wherever I've got a t in this equation here, I'm going to use this t that we've found over here and sub it in and get another equation. So x is equal to a half u plus v times t, which is v minus u, and that's over a. Okay, so let's have a look what we've got. First of all, we've got u plus v over 2 over 2a times v minus u is equal to x. Okay, so where can we go from here? Well, let's go expand this out and multiply our terms. Let's go. So we've got now v. If you think about it, this is the difference of two squares. We've got v minus u. We've got v minus u times v plus u. Now let's go ahead. You should recognize that when you're doing something like this, we're only going to have this squared, and then we're going to have take away this squared, and we're actually going to cancel out the other terms, and we'll show you why. So v times v is v squared, and so then we've got a plus uv, and then we've got a take away uv, which is just going to cancel these out, and then we've got a minus u squared. So this on the top here is actually v squared minus u squared, and on the bottom we have 2a equal to x. Now we're getting somewhere. Let's multiply the right hand side by 2a, or just cross multiply. Multiply this side by 2a is going to give us, well, these 2a's are going to cancel now, aren't they? We've got v squared minus u squared is equal to 2ax. And if I was to get this u over this side, we're going to add u squared. So we've actually got v squared is equal to u squared plus 2ax. Wow, that might be another one. Let's have a look. It is. It's equation 4. Wow. Okay, so we've just derived those equations. Now, look, this one, I'm not going to derive this one. This actually just comes from the others, and I guess this one is quite, the average velocity is we take the initial velocity, add it to the final velocity, divide it by 2, and that's our average velocity. So I've just derived those 4 equations for motions for you. Now let's go ahead and actually do a problem and show you how to just do one problem. Now you guys, it's not that bad. You just have to remember that when you're doing problems, you have to make sure that you write down what the question is giving you. Do not go ahead and just start plugging away. And sometimes you actually have to use 2 of the equations of motion. One to find a certain variable, or let's just say you needed to find a time, and then from there you can use that time to go ahead and find out whatever else you need to know. So equations of motion, I guess this is motion is the harder topic. This stuff isn't too bad, but I guess there's just so much to motion that if you don't understand this, you're going to have problems. So make sure that you are working at it, not just in class, but also at home. All right, so let's go ahead and do that. So our equations of motion, we know what they are, and I know them off by heart, so I don't need to refer to those anymore. You just need to make sure that you get them down in your books and start practicing with them. So let's go ahead and find a question from the textbook, and let's go ahead and sort of pick a harder one too. Okay. Let's do this one. A billiard ball rolls down from rest. So I might as well just sort of snip that, and we'll put that into. All right. So let's go to our Word doc. Let's go. Ooh, I don't want to do that. Let's do. I don't know what I've done there. One sec. Okay, so let's do this question. All right, now you're just gonna take some practice with these. It's not that bad, but it's really important that you write down what you know. A billiard ball rolls down from rest. So from rest, what does that tell you? It's telling you that's bloody the initial speed is 0. Okay, down a smooth ramp that is 8 meters long. Okay, so we know that this is 8 meters. That's good. So, you know, it might travel a distance. The acceleration of the ball is constant at 2 meters per second squared. 2 meters per second squared. Okay, now we know that it's showing us that there's 4 meters, so I'm guessing it might be sort of asking us something about, you know, halfway, what is the speed? Well, let's go ahead and do that. What is the speed of the ball when, oh, there you go, what is it when it's halfway? Okay, so that's the first thing. Well, first of all, let's write down what we know. Now, distance, this is actually known as our distance or displacement. We're just going to use x for distance or displacement, whatever it is. X is actually, we know that that is equal to 4 meters. We know that our u is 0 because it says at rest, and at rest here. And we now need to find the speed. Now, by looking at our formulas, you know, let's have a look at our formulas. I'll just write them out. We've got v is equal to u plus at. We've got v squared is equal to u squared plus 2ax. And you just have to know these. You will. We've got x is equal to ut plus a half at squared. And so on. And what else have we got? I guess they're the three main ones. Is there any other ones that we sort of need to cover? What have we got? V squared. Yeah, I'd say that they're your main three, to be honest. And then I guess you've also got this one as well. X is equal to a half u plus vt. Okay, so let's just say they're our four equations for the time being. Well, what is the speed of the ball when it's halfway? Well, we've got a u, a, and an x. So it's really important that you go ahead and write down what you know straight away. Now, which one of these is going to help us find the speed of the ball when it's halfway? Well, its initial speed is here, u, and its final speed for this sort of section is going to be v. So we need to find v. We've got u, a, and x. Well, we've got a u, a, and an x. Pretty bloody easy, isn't it? So so for part A, we've got v squared. Okay, so v squared is what we're trying to find. We're trying to find v is equal to u, which is initial speed. So it's 0 squared plus 2 times a. Well, 2 times a is 2 times 2 is 4. Times x is 4. So we've got v squared is equal to 16. Now we're not solving for v squared, are we? We're solving for v. So we're going to take the square root of both sides. V is equal to the square root of 16. Or we could just say that the square root of v squared. We're taking the square root of both sides, aren't we? So therefore v is equal to, now v is equal to technically plus minus 4 meters per second. In this case though, we're only taking the positive value. The velocity is 4 meters per second. Okay, so velocity is 4 meters per second. What is the final speed of the ball? Well, that's pretty simple, isn't it? The final speed of the ball, v, is equal to, what is v? So always sort of write down a question mark. That usually helps out what you're trying to find. You know that u is equal to 0, and you know that distance this time is equal to 8. We know that the acceleration is equal to 2. So it's actually using the same question. What is the final speed of the ball? So v squared is equal to u squared, which is 0, plus 2ax, which is 4 times 8 is 32. So therefore our velocity at the end of the ramp is equal to, we're going to take the square root of both sides, so we've got the square root of 32, which is, well, 32 is 16 times 2, 4 root 2 meters per second. Now root 2 is like 1.4, so it's going to be around about 4 times 4. It's going to be about 5.6 meters per second. Okay, without using a calculator because I don't like using calculators. All right, C. How long does the ball take to roll the first 4 meters? Okay, so this is where we've got to start using some different equations. T is equal to, we know that x is equal to 4 meters, and you've got to write these bloody down because you just won't know what to do unless you do. We know what the acceleration is, that is equal to 2, and we also know that u, our final initial speed, is equal to 0, and we could even tell you that the final velocity at 4 meters, we've worked that out over here in part A, which is 4. We've got so much information. It's just using the best one. Now, let's have a look. We've got a U, we've got an A, we've got a V, and we've got a T. So why not just use equation 1? Why not just use this one? You could use a few others though, couldn't you? You don't have to use that equation. We could use this one if we wanted to get the same result of t. We could use v squared. Well, this one does. Equation 2 doesn't have a time into it, and we could use perhaps this one here as well. X is equal to a half at squared. Now the initial velocity is 0, so that this section is going to be equal to 0 anyway. So look, I'm just going to use anyone, and this is where you're just going to have to play around. I'm going to use v is equal to u plus at. Let's sub in what we've got. We've got 4 is equal to 0 plus 2 times t. So therefore we've got, this 0 is obviously 0, so 4 is equal to 2t. So therefore t is equal to 4 divided by 2 is 2 seconds. It's going to take 2 seconds to get down to the first 4 meters. How long does the ball take to travel the final 4 meters? Okay, so this is where we've got to start, I guess, start thinking a little bit more logically. What is the initial speed? So let's consider that the ramp, we've got a ramp which is 8 meters, but we know that it's traveled. The initial speed there is actually 4 meters per second. And the final speed, well, we know that the final speed is around about this 5.6. Well, let's go ahead and use this. So write down what we know again. It's really important. 4. Acceleration is still constant. We can't use the equations of motion without a constant acceleration. 2 meters per second squared. And our final speed, let's not even use our final speed. We don't have an exact value there. So let's go for, now we know that it's going to travel it's going to travel from halfway to the red end. So as x is equal to, it's actually equal to 4 as well. So let's go ahead and see what do we need to find? How long does the ball take to travel the final 4 meters? Okay, so we need to find what t is. So make sure you write t with a big question mark. Now, it's so important that you're writing it like this, because if you don't, you're going to make stupid mistakes. You're going to go, oh, what formula do I use? Well, it's not that bad. It's really not. Let's use x equals ut plus a half at squared. X equals ut plus a half at squared. Okay, we could use that one. X is equal to a half u plus v times t. Well, we could use that one as well, or v is equal to u plus at. Well, I guess we're probably going to have to use our final velocity. Maybe I'll have to use a calculator. Okay, so v is equal to u plus at. Okay, so our final speed is going to be, I'm just going to say 4 root 2. I'm going to use an exact value, is equal to u, which is 4, plus a times t, which is 2 times t. Okay, so I'm going to rearrange this. I'm going to get the 4 over to the other side. We've got 4 root 2, take 4 is equal to 2t. And therefore, we're going to divide both sides by 2 to get t by itself. So we've got dividing both sides by 2 is going to give us 2 root 2 minus 2. and that's equal to the time. So the time it takes for that, well, 2 root 2, root 2 is about 1.41 times that is about 2.82. Take away 2, it's going to be around about, without me having a calculator, 0.82 seconds. So it's not going to be the time for the whole thing to get down there, because we're saying that time is equal to 0 at this point here. And it's going to then take 0.82 seconds to get down there from that point. So there you go. I've done probably one of the harder questions on there. It's now your turn to have a go at those questions. I'd like you to do every question from chapter 4.3. And look, I'm certainly going to give you some more time next class if you can't finish those off, and we're going to spend a lot of time with the equations of motion. So I hope that helps, and yeah, please make sure that you finish off some questions for homework, and I don't want you just to attempt the first question and that's done for the day. Thanks a lot. See you next time.